Hello, I'm Bryce Colcom, and I'm going to be talking about the design of an expert system coach for complex team sport. To give a little context before we get started, the focus of our project is the GMU men's soccer team. The objective of soccer is to score more goals than the opponent. In order to complete this objective, coaches have developed strategies through the use of formations which give their teams numerical advantages at different areas throughout the field. Coaches are faced with many challenges when coaching soccer. Players are autonomously distributed agents throughout the field that are constantly moving throughout the whole 90-minute game. There's no real instruction or stoppage times until halftime when coaches are able to speak with their players. This is different from sports such as baseball, where play is stopped and players can reset after every play. Because of this, players are always having to adapt to the situations which are around them. Coaches traditionally have relied on their own expertise to see patterns in which they need to change their strategies. However, the use of data analytics and this new generation of coaching has allowed coaches to see the full complexity of the game. This is very important because coaches are put under lots of pressure to succeed. Here's the current coaching process of both the traditional as well as new generation coaching. Coaches are assessed on their performance in both conference tournaments, in GMU's case, the Atlantic 10, as well as the NCAA tournament. Tournaments are decided on teams' RPI scores, which consist of three parts: team's winning percentage, opponent's winning percentage, and opponent's winning percentage. So when coaches have a strong strength of schedule, their RPI can greatly improve. Looking at some top programs in the NCAA, their coaches receive on average about $67,500 more per year than an Atlantic 10 coach. St. Louis is historically the most successful Atlantic 10 team. So in order to replicate St. Louis's success, George Mason must win Atlantic 10 Conference Championship 3 times every 5 years, receive an NCAA bid 6 times every 10 years, receive an average RPI score of .56. This will result in helping to close the salary gap of the head coach of $67,000. Next, I'll go into stakeholder analysis, problem and need statement, and concept of operation. This is a diagram which illustrates all the stakeholders involved in our system. The main stakeholders are the head coach, assistant coach, university, and players. This is where the main tensions rely. This leads to our problem statement of George Mason University men's soccer team is not consistently achieving NCAA bids at a high rate. Because of this, there are a few needs that need to be met. Coaching tool that uses coaching expertise as well as soccer game data to understand the complexity of soccer. Coaches are seeking a competitive edge, and GMU needs to reach the tournament 3 bids out of every 5 years. Here is our concept of operations, with our system covering the blue boxes. Next, we will go over the simulation. For our simulation, we would like to simulate a full soccer game. The inputs into this simulation are probability pass map data, which I will speak about later, as well as expert coaching rules, which were derived from the coaches. The outputs are many different statistics, such as passing percentages, as well as a summary of all those statistics. Here is the running of our simulation.
Okay, so I'm going to explain how our simulator works for soccer analytics. First thing you want to do is you want to download the simulator zip file. As you can see, I already have it saved on my desktop, so I can just get going. Click on it, then open the simulator file inside it. And then you want to look for a file called sim0210. It's right here, it's an executable file. Open it, and then our GUI pops up. Then you want to do is you want to set your formation that you want to simulate, and as well as the team you want to play against, and the goal weight set it at 100, and then you want to hit simulate. Now you can either watch this game in real time, which is right here highlighted in the yellow, or you can set it at the max speed so you can get the result quicker. I'm going to set it at max speed and wait. Okay, so now once the full 90-minute game has been played, you want to hit the exit button and look in the top left-hand corner as opposed to the X button. This way the results actually get saved in the file. And now you can see that the results are generated in the same folder as where the simulator was saved in. There are two Excel files. One contains a game summary right here, the summary files, as well as a sim log, which displays all the passes that are made in the game. What you want to do is you can just open them up and then see the results. And this displays all the passes that occurred in different parts of the field, passes home, midfield, passes home offense, and all that good stuff. And that's it.
In order for our simulator to run, we rely on data collection from 5 games during the 2015 season. Here is Instat pass diagrams, which we are able to input into our zone grids, which are marked on the field. From this, we are able to create an entire game full of data and create probability maps. This is an example of a probability movement map. These numbers represent where the ball will move throughout the whole zone. This is a success map. This map shows the percentages that a pass will be complete when moved from one zone to another. This is the ball movement interaction diagram. The way the ball moves on the field through passing as well as dribbling is shown here using different distributions. The focus of our project is very much team-based, but in looking at a field, we separate it into many different areas. The left zone, middle zone, and right zone, as well as the defensive zone, midfield zone, and offensive zone. This could give us better results when analyzing the data. Our expert coaching rules were derived from GMU men's soccer coaches and were input into our system. Here's a comparative score differential when GMU plays American using our simulation. As you can see in the first half, the score differential is very good for GMU, while the second half it is very good for American. This phenomenon occurs because of sparse data. The data needs to be supplemented by having a base of 10 games of collected data. The problem is the ball moves and is trapped in certain areas of the field throughout the game, which leads to this result. Next, I will talk about results and conclusions. While the data did not provide accurate results, we were able to create our own probability maps to give insight into the sport and familiar patterns surrounding the sport. By doing this, we were able to combine all 5 games of probability maps and change the success rates, and this gave us several conclusions. These 2 graphs show what happens when the success maps are incrementally changed, ranging from 0.1 to 1. This means that the passing percentages of Team A ranges from 10% to 100%. Team B is consistently at 50% success, similar to a realistic collegiate team. As you can see, in both goals and shots, right around 70% completion rate, there is a turn for the better for Team A as they score more goals as well as take more shots. Because of this, Team B gets less shots and less goals because they don't have the ball as much. In another simulation, we created 2 equal teams which had equal probability maps as well as equal success maps, Team C and Team D. After playing them against each other, you would think that the average goal difference would be 0. However, Team C won 40% of the time, Team D won 40% of the time, and there was a tie only 20% of the time. The results from this, as you can see, is many events are random in soccer, and a small bounce could lead to a goal which has a massive impact on the game of soccer. So simulating these two teams provided necessary results that many events are random. Contributing to this randomness is lucky bounces, unlucky touches, and these are big parts of the game which really affect the outcome but cannot be changed by coaching and coaching changes. When two teams play each other that are very evenly matched, some of these intangibles which cannot be quantified or coached are often what determine the winner and loser. Coaches can really only do so much to predict the outcome of a soccer match, especially when playing an equally matched team. Some implications for the stakeholders is that coaches can only control so much of the game. Athletic directors as well as the university should not put as much pressure on coaches because of these findings, as well as players are not always at fault for these unfavorable results due to bad touches or bounces. As a last thought, only those who can see the invisible can do the impossible. Thank you.